In example number 1, you're asked to compute the derivatives of the following functions. So I'm going to write these. I'm going to show you them in both the different notations. So we're going to say f prime. Whoops. Well, before I do that, let's figure out what the functions are. So a, we'll let that be f of x is equal to x to the 8th. Part b, we'll say that is g of x, and that's equal to x to the 12th. And for c, we'll just call that h of x. And we'll let that be x to the 99th power. Okay, so to answer these questions, for A, so here's my solutions. So we're going to use the power rule here. Okay, it makes it very quick. We don't have to do this by limits anymore. Okay, we're just going to use the rule that we just went through. And so all we're going to do is we're going to say, okay, first, defined dy dx, what we need to do is we need to, and we can actually do it like this, we can say if y was equal to x to the 8th, then that implies that dy dx is equal to d dx. Tells us we have to take the derivative of x to the 8th. And so the derivative, now this variable right here has got to match this variable. So d dx of x to the 8th is 8x to the 7th. So we would write dy dx, that's the same thing as f prime of x, is equal to 8x to the 7th. Again, this Leibniz notation is going to become useful later. So I'm going to do a lot of problems involving it, but we'll switch back and forth. So here I've got y is equal to x to the 12th for b. And so if we want dy dx, that's going to be equal to d dx of x to the 12th. You can think about it. It's not technically correct, but if you want to, if you have something like this, y is equal to x to the 12th, you can think about it like you're taking d dx of both sides and so on this side you can think about it like a fraction. It's not truly a fraction, but you can think about it like a fraction. So d over dx times y would be dy dx, and d dx over this. Now this is an operator here, and so that's the part that's confusing, because a lot of students want to say that this is dx to the 12 over dx, and that's not true. This just stands for we have to take the derivative, and so we get 12x to the 11th. So dy dx is equal to 12x to the 11th. Why is that? We take the 12, we bring it down front, and then we subtract 1 off the power. And so remember that this is now g prime of x, because that's the differential, or the derivative of g. So c is y is equal to x to the 99th. That implies that dy dx is equal to d dx of x to the 99th. Using the power rule, we get 99x to the 98th, which is h prime of x. Okay.